Assalamualaikum and a very good day to Professor Madya Dr. Muhammad Zahir bin Hassan, our lecturer for Vehicle Brake System. My name is Muhammad AZAHAR bin Muhammad Noor with my team member NADZIRAH binti MUHSIN, Muhammad NABIIL bin Nur HISHAM, Muhammad QAYYUM bin Muhammad FUAD, and finally AHMAD NUKMAN bin JAMALUDIN. Today, we will do our lab report presentation on Lab 4, Disc Brake Inspection, Removal and Refitting. We start off by removing the tires. The tool that we need to use to open the tires is a wrench of 21mm size of bolt. But remember, do not fully open the bolt. Next, use a jack to lift up the car so that we can remove the tire and do inspection on the brake disc. After that, it is important to slide the jack stand so that it can hold the car. Afterward, fully remove the bolt, then detach the tire from the car. Here we can see the brake disc component that we will do inspection on.
This is the cylinder body for the brake disc. To do further inspection, we need to disassemble it using proper tools. As we can see, the guide pin is in a good condition, which is straight, not cracked and not bent. When we open the component, we can see the brake pad and piston that perform the braking mechanism. We need to detach the brake pad and mounting bracket. For this inspection, we are using vernier caliper. The first measurement that we need to take is the disc thickness measurement. In this step, we have measured 6 different locations of this rotor. The average thickness that we get is 21.25 mm. The bolt need to be attached back but not tightened. This will help us easily rotate the disc rotor. Use the vernier caliper to measure the thickness of the brake pad. For the outboard brake pad, we got 6.95 mm and inboard brake pad is 6.9 mm. They are both in good condition. In this step, the instructor is showing us how to use the dial gauge. It is important to set the gauge head correctly on the surface of the brake rotor. When running the run-out measurement, it is indicate that the measurement are tend to give negative values. This is caused by the groove surface of the disc and the rotor is not suitable to use. The disc brake have certain minimum thickness to pass the inspection and usable test. Next, we are going to do the rub test. Using a chalk, we rub all over the surface of this rotor. We attach the bracket to its original position. Use the chalk to do the same procedure on the brake pad. Install back the brake pad onto the bracket. We can start the rub test by manually rotate the disc rotor. The result that we get is uneven worn down only wear at the side. It also shows the groove surface due to rough surface of this brake. The cylinder body is removed. This is done so that we can do inspection on the caliper and piston. Using air pressure, we pop out the piston from the cylinder body. We found out that the piston has bad surface condition with rust make it hard to put it back into the caliper. Further inspection, the cylinder bore also have bad surface condition with rust. It also have grooving marks. Now, we need to assemble back the piston into the cylinder body. When all inspection is done, we assemble back the disc brake component.
Hi, Assalamualaikum. Okay, today I present about the question. Okay, so now the question is, based on your finding, what is the condition of the brake pad? Should be replaced a new pad? Okay, the brake pad are uneven, worn down because the inbound pad have 6.9 mm thickness and the outboard have a 6.95 mm thickness. It does not need to replace because the minimum thickness to pass the inspection test is 3 mm of friction material. From the rub test indicates that the pad have uneven worn by only wear at the side. It also shows the groove surface due to rough surface of a disc brake. Second, the question say the list two causes of the rotor thickness variation. What is the correct repair procedure of the thickness variation? There are two causes of a rotor thickness variation. First, excessive lateral runout. Lateral runout is the rotor wobble from the axis back and forward. And secondly, the repeated contact with the brake pad over the time causes that the section of a rotor to become worn, or brake pad material are spread uneven to rotor surface. Okay, the correct repair procedure is, first step is take off the tire by loosening up the lug nut and jack up the car a little bit to get good access of the rotor. Then put the removed wheel into underneath the car for extra safety in case there are failure of the jack stand. And third, check the thickness of the rotor by using vernier caliper. Also check the play in the wheel bearing and corrosion on the mounting surface. Number 4, use the dial gauge to measure runout in the rotor and hub assembly. 5, if the rotor did not pass the minimum thickness, the required by manufacturer, and the rotor need to replace. 6, if the rotor have an excessive amount of thickness, it can be repaired by using sandpaper. Use the Morse code sandpaper and then to the fine sandpaper. 7, repeat step 6 until desired thickness is achieved. And the last one, reassemble the wheel and make sure the bolt and the lug nuts are torqued down to manufacturer recommended.
The question states that, what do you understand about run-out measurement data? Run-out measurement data is the relative measurement of the surface flatness of a disc brake rotor. So essentially, we are checking to see whether the rotor disc is fully flat or not. And if not, how much of it is not flat and by how much. So how do we measure it? It is measured by using a dial gauge. The dial gauge is positioned next to the rotor and is pushed slightly towards it so that its contact point is pressed onto the rotor. The graduated scale is then rotated until the zero on the scale reaches to wherever the pointer is. The rotor disc is then rotated and the reading from the dial gauge can fluctuate from positive to negative. This fluctuation of measurement indicates that the surface is not flat and thus the range of fluctuation is obtained as data. The next question is, what is your finding for the guide pin or lock pin straightness check, and what can happen to your disc brake system if guide pin or lock pin is not straight? Upon examination, it is found that the guide pin is straight, but what happens if the guide pin is not straight? First, we have to look at the function of a guide pin. The guide pins are responsible for guiding a proper angle for how the brake pad meets the rotor disc. During a braking process, the brake pads are supposed to be pushed towards the disc to create friction and slows down the vehicle. However, if the guide pin is not straight, they cause the caliper to bind and hence restrict its ability to move freely. This restriction causes the brake pads to clamp down onto the wheels unevenly, and the result is an uneven pad wear.
And the last one, conclusion. Okay, in conclusion, we can know how to properly inspect the condition with being able to identify and name all disc brake assemble parts. We also learn how to calibrate and use dial gauge correctly. That's all. Thank you.